All right, in this short video, I'm going to show you how to use the random number generator. That is a very useful function that allows us actually to simulate a lot of different things. For example, simulate portfolios, right? Okay, so random library. In order to generate random numbers, we need to import library called random. And this is very popular library, which basically is included in the installation of Anaconda, in any standard Python installation. So you shouldn't be required to install that through the terminal or console. So we just go ahead and type import and the name of the library, which is random. Run this line, shouldn't give you any problems. So now what I'm going to do is kind of explore a little bit what the random library includes, right? So I'm going to say rand num equals, and then I'm going to call the library name random, and then dot, and hit the tab to see what's available. As you can see, library random can generate for us numbers that are coming from different statistical distributions. For example, beta distribution, then there is exponential, there's gamma distribution, Gauss, which is basically normal distribution, log normal. What else do we have? Let's see, triangular distribution, uniform, Weibull, so the most popular distributions. But for the purposes of this video, I'm going to use the function random. So let's go ahead and click that. I'm going to say parentheses and hit Shift Tab just to see the signature of this function. And the function tells me that the signature tells me that this function generates a value in the interval between 0 and 1. So therefore, it's kind of useful for example, implementing the random weights that we can give to our stocks in the portfolio, right? So if I have, let's say, 10 stocks in the portfolio, I can go ahead and generate 10 different weights from 0 and 1. And then, of course, the problem is going to be that they don't add up to 1. So I have to kind of normalize them, right? So that the modified values, they do add up to 1. But my initial values for the weights can be chosen by using the random function, right? So now I generated my random number, and I'm going to print it. I'm going to say, hey, Python, show me what you've generated. So I'm going to run this one time. You can see that I generated 0.6635. If I do it again, next time around, it's a different number, 0.9922. Do it again, 0.0948, okay? But the problem in this case is this. If I'm going to have the same code as you, and the code is using a random function, right? When you run the code, you're going to get your own stream of random numbers. When I'm going to run exactly the same code, I'm going to get a different stream of random numbers. And that means that the results are not going to be the same exactly, right? So therefore, I may have, certain result. Your result may be close, but it's still going to be different, right? So in order to make the results more reproducible, here's what we need to use, okay? At least for the project purposes. Let's go ahead and call a different function in the library random. So I'm going to say random dot, and I'm going to call the function seed, okay? Seed, and doesn't really matter what you send to the function seed actually receives, it needs one parameter, okay? It doesn't really matter. Just whatever you like. So I usually use number 100, and that's it. So why do we need the seed? Let's see what happens. If I run now this command, line number 85, right? It gives me the random number 0.1456. Okay, cool. If I do it again, it's going to give me the same exact value. Okay, if I do it again, it's going to give me the same exact value. All right, let me actually generate a second random number. I'm going to call it rand number 2, and again it's going to be library random dot function random. Okay, and I'm going to say print the second random number for me. Okay, 0.4549. Okay, cool. Now let me go ahead and run this first line again, and it's going to generate the same exact number for me, 0.1456. And I'm going to generate the second random number again. And look at that, I'm getting the same exact value. Okay, so in other words, when you first call the function seed, and it doesn't matter what number you're sending to the function seed, okay? can go ahead and send number 1. Run it for the first time. Random number 0.1343. Second random number is going to be 0.8474. If I do it again, seed 1 and first random number, the value is the same. And the second value is also the same, okay? So the point being here is, depending on what value you are using in your seed function, pretty much it determines what sequence of random numbers you're going to get, okay? I can generate a million random numbers after that, okay? But if I rerun the code again, using the same seed value, I'm going to get exactly same sequence of random numbers. So essentially, your sequence of random numbers is completely determined by what seed you're giving to the seed value you're giving to the seed function, okay? And that is done for the purposes of reproducibility again. So basically, if you have the same code as me, and you're using the same seed value as I do, then the set of random numbers that you and I are going to get by running the same code with the same seed value, they're going to be the same, right? And therefore, our results should look identical, okay? While if we're using different seed values, then your sequence of random numbers will be different from mine, and therefore the results might be slightly different, okay? So if every team in the class is using the same seed value, we all should end up with the same results for the project, okay? So this is my short tutorial for how to use the random library, random function of the random library, and the function seed.